Thanks for looking in. I worked for BBC Television for 25 years as a sound man, and I'd like to pass on some of the wrinkles and tips that I've picked up during that time. In our first video, we talked about how moving coil microphones work. We'll be looking at other types in future videos, but this video is all about connecting up. All but the cheapest mics have a 3-pin male XLR connector built into them, and this mates with a female connector on the cable, and the other end of the cable is plugged into your mixer or camera or whatever. Microphone cable is usually a pair of wires enclosed in a sheath of metal braid. Here are the conductors. This is the outer sheath, which surrounds these two wires, which actually carry the tiny signal. The outer sheath is called the ground or earth connection, and is connected to the metalwork of whatever the mic's plugged into, or in the case of a plastic equipment, it's electrical earth. The outer braid is to screen the signal from interference from electrical or electromagnetic fields. The two inner conductors carry the tiny alternating signal current. And actually, a moving coil microphone will work with a cable without an outer screen. It'll pick up, without this screen, it'll pick up noise and mains hum very easily unless it's properly balanced. I'm going to cut this earth wire while I'm talking into this SM58 and you'll see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. However, capacitor or condenser mics won't work without the outer braid connected. As I said, capacitor or condenser mics, like this one, won't work without the outer braid connected because the power required to operate the preamp in the microphone depends on having the earth connected for its power supply. This is a condenser mic, it's plugged in. Now, just like the other one, I'm going to cut the earth wire. More on this in a later video when we talk about phantom power and condenser microphones. The standard connections for the XLR connectors and cables are like this. Pin 1 is the screen, or earth terminal, that's pin 1. Pin 2 is the hot or positive terminal, that's that one. And pin 3, the middle one, is the cold or negative terminal. Now this hot and cold labelling is just a convention, but it is very important because if everybody sticks to it, then the output from the diaphragms of all the various microphones that are manufactured will move in the same sense, whoever happens to make them. Why does this matter? It matters because if microphones are used close together, then although the diaphragms are moving together, if they're connected the other way round, there'll be a cancellation of the sound, particularly at low frequencies. This personal mic sounds fine. Hello, hello, personal mic. So does this. This sounds absolutely fine. And together they sound like this. Absolutely fine. Now I'm going to change the sense or the phase of one of them with this phase reversing barrel. It's just an empty tube with the connections to pins 2 and 3 reversed. I'll just plug it into the mixer. I need the sex converter, excuse the word sex. Right. Now listen, all the bass is gone, and as the mics move around it sounds very strange. The connections to the diaphragms are now reversed, effectively meaning that the diaphragms are moving in opposite directions to each other, and we're getting all sorts of cancellations of the sound. Imagine if this happened when you were trying to record music. It's exactly the same with your speakers, by the way. If you accidentally connect them out of phase, the bass will disappear and it'll all sound wrong, with no bass and no stereo imaging. I hope you found this interesting. Do let us know if you've got any suggestions or questions. Thanks very much for watching. Bye for now.